Hey, what's up guys? Welcome back to another video in the Spigot series. In this video, I'll be teaching you about packet events. Packet events is a library for working with packets in Minecraft. And I'll have a link to this GitHub here and other links in the description below so you can check it out yourself really easily. So as the description says, it says packet events is a fast and efficient multi-platform packet processing library. Our packet wrappers are easy to use with multi-version support. With our API, you can write code that runs on Spigot, Bungee Cord, Velocity, and Fabric. So this library is really powerful for multiple reasons, and I really like it because not only is it able to listen to packets that are sent to the server or from the server, it has built-in packet wrappers so that you can easily work with your packets without having to rely on third-party wrappers or having to read the fields from the packets explicitly. Not only can it do those really important things, but again, it also works with Spigot, Bungee Cord, Velocity, and Fabric, so it's multi-platform, but also on top of that, it's multi-version. So this library here supports versions 1.8 to, at the time of recording, 1.20.4, which is the latest version of Minecraft. So those are some really cool benefits, I think, but you're going to see in a minute just why packet events is so awesome, just because the way that you write the code and how easy the library is to use when you're actually writing code is really just amazing. It's very simple compared to other options. And speaking of other options, I've made a video in the past understanding packets that is very popular, and it uses something called protocol lib, which is a library that people have been using for a very long time to work with packets in Minecraft plugins. And it's still a great option, it's still very popular, but it has a couple of flaws with it. It doesn't really support the latest version of Minecraft, at the time of recording at least, and people have been having issues with newer versions, it looks like, in the comments. And also using the library is a little tricky compared to how easy it is with the new packet events library, so especially because it doesn't provide the same wrappers that packet events does. And so you can use either one, it's really up to you, but today I'm going to be showing you guys this new alternate option called packet events that is becoming very popular recently. And thank you to Dragon DC for suggesting this to me. If you also want to suggest videos or any kind of tutorial that you want to, then make sure to join our Discord server, link in the description below, and in the suggestions form you can leave any suggestion that you have. I would say the only thing that's lacking about this library is the documentation. That's the only thing that I found an issue with so far, is that the documentation is pretty, kind of bad, but it does have a couple of good examples in this example repository here. So if we click this will take you to the example repository where you can view 5 different examples of how to actually use the library. So now you may be wondering, what are packets? And for this, I recommend that you go check out my Understanding Packets video with protocol lib that I've just brought up. I gave a really good explanation there that a lot of people enjoyed, so make sure you go check it out so you can actually understand what packets are, how they work, and how we're actually using protocol lib to intercept packets and send packets and all that fun stuff. So I think it's still important to know how to use protocol lib in general, but if you want to skip that part, you can. But anyway, so just as a quick little recap, I guess, packets are essentially chunks of information sent on a network, okay? And so the network in this case is going to be your Minecraft server and the client. The client is your Minecraft game that you have. So the connection between the Minecraft server and your client, your game, is a network. And so the way that your computer and the Minecraft server keeps in sync with one another, aka knowing how, where players are, if a player hit another player, anything that happens on the server, it has to be synced between the server and the client. A really good example is if a player moves to another spot on the server, those movement packets will be sent from the client to the server, and then the server should relay that information to the other clients on the server so that other players on the server know where you moved to, if that makes sense, okay? So again, packets at just the highest level are just chunks of information sent on a network, with the network being the client and the server. And then you have different types of packets. So you have handshake packets, you have status packets, you have login packets, and you have configuration packets, and then you have play packets. The packets that we're going to be working with the most is going to be play packets, because this actually deals with the gameplay of the server. So you can see a full list on this website here. I'll have a link for this in the description below as well. This is the ultimate reference for how you know what packets are available with Minecraft and how you can read information from it, how you can use them, all that fun stuff. So you can see all these different types of packets. So particle packets, hurt animation, explosion packets, entity event packets, chat suggestions packets, clear title packets, boss bar packets. Those are client-bound packets, meaning that they're sent from the server to the client. But then you have server-bound packets. If we scroll down here, server-bound packets, as the name suggests, are packets that are sent from the client to the server. So another really good example is the chat message packet. So this is a server-bound packet. So whenever a player sends a message on a server, that's going to be a client sending a chat message packet to the server so that the server knows that a player just sent a message. And then the server's job will be to relay that to other players on the server so they also get the same message that that one player sent, right? So if we scroll up here, we see that there's a client-bound packet that corresponds to that. And it should be this one, player chat message. So once the server receives that original chat message packet from the client, the server can then send another player chat message packet to the other clients on the server telling them that same information that, was sent in the chat by the other player. So if we just click this, it'll give you all the full information about what the packet contains. So that it has a packet ID, that's the identifier of the packet. We have the type of packet, it's a play packet. It says what it's bound to, so it's a client-bound packet, meaning that it's sent from the server to the client. And then after that, you pretty much just have all the information that the packet will contain and the payload of the packet. So that's just a small recap of packets. If you want to see a full explanation, like I said, check out my Understanding Packets video, okay? Okay, so the first thing that we want to do is install the API package dependency on our Maven here. So the easiest way to do that is to go to the GitHub and then go to how to set up packet events. And now if you're using Maven or Gradle, you can just copy this information. So let's copy the repository here. And we'll paste it here. And then we'll come back and we're going to copy the dependency. Paste it here. And then now we need to change the platform here to whatever platform we're using. In this case, we're using Spigot, right? So we'll literally just replace platform with Spigot. There we go. So now we just click the Maven reload button at the top right. Now what we have to do is go to our main plugin class here and set up the initial stuff just to get the API to work. Now realistically, you would just go to the packet events examples repository and they'll just, allow you to copy and paste this information here. But since we're here, I'll just, code it through with you guys and explain a little bit like what's happening. So everything that we're going to need here is going to be accessible through the packet events class. So we can do packet events dot get API. And then you have a bunch of stuff here that you can use. So you have a player manager, so you can double click that and it will give you some stuff to use. So you can send packets to players, receive packets, get the user, get the ping of the player, get the client version. That's pretty useful. Other cool stuff. And then you have other different types of managers that you can work with, like the event manager. So this allows you to register listeners, which we'll do in just a second here. But what else? We have settings, so we can set settings. We have a server manager, we have a protocol manager, we have a netting manager, we have an update manager, we have a version manager. So with all that said, there's a lot of different classes that you can play with here to do stuff with this library, so I recommend checking all of them out. The only downside here is that it doesn't give you the documentation when you do Control Q. So what you would do in that case is actually go to the Java docs, which I'll link below, but it's also available on their GitHub. So on the Java docs here, you can view all the documentation for what these classes do. And my only complaint here is that it's clearly out of date. I think we're on version 2.2.1, but this is 1.8.4. And it's kind of noticeable because when I go through this documentation here, when I look in the Java docs, you can see methods that don't exist anymore or are just kind of incorrect. And on top of that, there's no search bar, which is actually possible with Java docs, but this one does not have it. So you can't search for stuff that you're looking for specifically. So if I really wanted to figure out what a certain method does, I could easily just search it on other Java docs, but for this one it does not support that. So this is what I mean when it comes to like bad documentation. That's the only complaint I have with this library so far, is that the Java docs are here, which is very nice. That's a really good plus. You can go through these and it has good explanations for what a lot of these things do. But again, it's not searchable, it's out of date. And then on GitHub, the wiki doesn't really have any explanations. Well, it does have some, but it doesn't really have many explanations for how to even use the library. It's very reliant on the code examples that they provide, which is also kind of small. So even though I like this library a lot, I'm just giving my honest review of what I have found so far. But anyway, so if you want to find, for example, what the player manager does, you just click here, and you kind of look around, so packet events. And so now we just need to find player manager, but it doesn't exist in this version, so that's an issue. But if you just look around though, you'll find other stuff. So it might be available in player utils. If we just take a look here, player utils, and then we have get channel, get ping. So yeah, these are a lot of the methods that are available in the player manager. So this looks like the old version of that. But in general, just, use the Java docs when you're kind of confused on what something does, okay? This is here for you to utilize, and hopefully they update it. So the first thing that we're going to do is just tell it that we're using Spigot. So we're going to do packet events.set API, and we can do Spigot packet listener or packet events builder dot build, and then this for the plugin instance. Now we can configure settings. So packet events dot get API dot get settings, and then we have a few settings here that we could utilize. So feel free to check all of these out, see what they do. But we're just going to set a few of them, so we can do something like check for updates. We can set that to true because I think it's pretty useful to check for updates so that we can have the latest version of this API for us to use. Another one is bstats. I don't know what the default is for this one, but I'm just going to set this to false because what this will do is essentially report statistics to bstats, which is a statistics tracking thingamajiggy. So we don't really care about that or want to do that, so we're going to set that to false, okay? Another one that's provided in one of the code examples is something called re-encode by default. It's not actually present in the Java docs because it's out of date, but I'm going to set it to false because I don't know what that does, and I just don't want to, deal with the repercussions of it doing something that we don't want to do. And then after that, once you set your settings, you can go and load the API by doing packet events.getAPI.load. And this actually reminds me, we have this in the wrong place. So currently it's in the onEnable method, but since we're loading the API and setting up some stuff here, we want to make this in the onLoad method, which is not something that you see often with the Minecraft plugins, but you can actually do that. So you can go to code, override methods, and you can find onLoad. And so as the name suggests, when the plugin is loading before it's enabled, this will be triggered essentially, so you can run whatever code you want to run. So we're just going to put that inside of there. So this is where we set the API, set the settings, and then load it. And then after this, in the onEnable method, what we want to do now is register our packet listeners. We don't actually have one yet, so we're going to leave this one kind of blank. But after that, you also want to then packet events.getAPI.init. So it's going to initialize the API, which kind of makes sense because it's onEnable. So initialize and then load, go ahead and load. And then for ondisable, you're going to do a very simple one. So packet events.getAPI.terminate. All right, so one more thing that we have to do is go to our plugin.yml and add the dependency. So depend, then we could do a little list here. We could say packet events. So since this plugin depends on packet events, we need to set it as one of our dependencies here, okay? So anyway, now that we have set up all the initial setup stuff, we can go ahead and actually create our packet listeners. So the goal here will be to show you guys how to create a packet listener so that we can listen to packets sent to the server and from the server. And then I'll be showing you guys how to send packets as well, okay? So let's go ahead and start with a new listener, a new Java class. And we're going to call this the time listener. You can call it whatever you want. That's just the name that I think kind of fits here. Because what we're going to do is listen to time packets and then make it so that players' time does not change when they're on the server. So what you want to do is implement the packet listener interface from retrooper.packetEvents. There we go. So now what we want to do is override different methods depending on what we're trying to do. So we're going to go ahead and go to code. We're going to go to override methods. In here you have different options for what you can do. So you have user connect, user login, on user disconnect, on packet receive, on packet send, on packet event external. Now we don't really care about any of these other ones. We just want to kind of focus on general packet receiving and sending. So we're just going to select both of those by holding control, click OK. So you may be wondering, how do I know which one's which? And so the way that you would do that is just remember that this is always from the perspective of the server because the plugin lives on the server, right? So when it says packet receive, this means that the server is receiving a packet. So this would be the server just simply intercepting client or server bound packets, right? And then this one is packet send. So since it's from the perspective of the server, this is when the server is sending packets from the server to the client. And we're just going to go ahead and choose a packet here for us to listen to. And so the one that I want to start with is the update time packet. So we're going to click that. And so this gives you an explanation of how it works, what it does, what information it contains. So it says update time. Time is based on ticks, where 20 ticks happens every second. There are 24,000 ticks in a day, making Minecraft's days exactly 20 minutes long. The time of day is based on the timestamp, blah, 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 blah. We don't really care about that. So this is a play packet, so it's dealing with gameplay. This is bound to the client, meaning that it's a client-bound packet sent from the server to the client. So that means that we're simply going to be using this method here specifically on packet send to intercept a packet sent from the server to the client. So this packet is going to contain two pieces of information, the world age, which is a long, and then the time of day, which is a long, okay? So we're going to make this very simple, okay? The goal of this will simply be to listen for time update packets, and then when we receive one in the listener, we're just going to cancel it, just like we would a bucket event, so that the player never receives any time update packets, meaning that their time never changes, okay? So if we go back to our code now, the first thing that we usually want to do is check to see what type of packet it is, so we can do if event.get packet type. And then now we can do equals packet type dot, and then now we can choose what type of packet it is. We know it's a play packet. And now we choose client or server. This one's always kind of tricky for me to remember, but this is, I like to think of it as the origin. So since this time packet sent from the server to the client, this would be server. And then now we simply choose the enumerator for whatever packet we're trying to detect here. So all of these names are pretty self-explanatory. The names don't exactly match the documentation, but they're pretty close. So in this case, we want time update, of course. And then we can go and get rid of this one for now. We don't really need that. So now we're just going to print a message where we can say time update packet intercepted. And then now we can go ahead and do something like event.setCanceled to true. So this will simply make it so that the packet is never received by the client because it's canceled when it's intercepted here. All right, so now that we've finished our basic packet listener here, what we want to do is actually register it. So if we go back to our main plugin class here, we can register it right here by doing packet events.getAPI.getEventManager.registerListener new time listener, which is our class that we created for our listener. And then after that, we could set a packet listener priority, and we're going to set it to just normal because we don't really care. I actually don't exactly know how this works, and I tried checking the Java docs to find out, but it doesn't explain it. I couldn't find this method here that accepts the packet listener priority, so it might not exist in that version of the Java docs, okay? But maybe I missed it, I don't know. So I'm just gonna set it to normal because we don't really care about priorities for this very basic plugin that we're doing here. And before we throw it on the server, there's actually one thing that we have to do. We have to actually get the plugin API download and throw it onto the server first. So I'll have a link for this in the description below, but this is the Packet Events API plugin that you can actually download and put on your server, similar to how you would do it with like Vault or Protocol Lib. So you just simply go ahead and download this and then put it into your server's plugins folder, just like any plugin. The alternative to this option here, where you have to download it separately and then make sure that you include it into the server, is actually something called shading, which is essentially taking the API code and then automatically injecting it into the plugin whenever you build it using Maven. So that will make it so that whenever you distribute your plugin out to like a server or just, on Spigot, if you're selling it there or something like that, it'll include packet events automatically, and you don't have to make it so that they have to go and download this here and then include that on the server. So essentially it's just a way of having it built into your plugin. But for the sake of convenience, I'm just going to go ahead and do it this way. If you want to know how to do that, they actually do have documentation for that on the wiki for packet events, so make sure to go check that out if you're interested in that. Alright, so I'm going to go ahead and run this now, throw it on the server, and let's go ahead and test it out. Alright, so we're on the server now, and if we look around, it doesn't look like the time is changing. It looks like it's staying dark, and we can wait here for a while. But if we check the console, that will help us determine if it's actually working or not, because we have that output message. And here we go, we see standard output, time update packet intercepted, and then we know that we're canceling it right after that. So we can assume that it's being canceled, but another way that you can test is by doing time set day, and that did nothing, it didn't make it day. And also if you do other commands like day, anything that would on the server side change the time to day or change the time in general would not work. And that's because we're canceling any time packets from reaching the client from the server. The thing is though, if you look closely here at the moon, you will see that it does move. It is moving very slowly. So if we actually wait here for a while, it will become day again. So how can that be? How can we run commands like /day and it doesn't change it to day, but it still actually changes the time over time? That is because even though the server's not telling the player what the time should be, this client here that I'm playing with is still keeping track of time on its own. So in that case, since we're blocking any way for the server to tell the client the time has changed or update the time in any way, how can we make it so that the time does not change for the client as well? What I'm actually going to do here is just wait to the end of the video to show you guys this, so stay tuned. I'll show you guys how to fix this specific time update listener so that we can actually make sure that the time is fixed at a certain number. So now what I want to do, guys, is give you a little bit of a more advanced example here. We're going to make a packet listener that could listen for whenever you hit a sheep or a pig or some kind of animal. So that will show you more how to extract information about packets. And then if they did hit an animal, we're going to go ahead and make it so that we send a packet that sets the player's health to a random value, okay? So what we're going to do is make a new class here. So Java class, and we're going to call it animal hertz listener. And this one is going to be another packet listener. So we're going to do implements packet listener. And so now we want to override whatever. So now we want to override, so we can go code override methods, and we want to choose whichever one corresponds to what we're trying to do. So what are we trying to do here? So we're trying to detect whenever a player hits a sheep or any other animal. So this would probably be a on packet receive one that we want to use, because we're trying to intercept packets that are sent from the client to the server, which is the player telling the server that it just hit a entity like a sheep or something like that. So that's why we're going to choose this one here. So now we just need to figure out what packet actually does that. So let's go back to the documentation and see if we can figure it out. So we just scroll up all the way here. This is going to be a server bound packet, right? So we're going to scroll down to server bound packets. And we want to find one that kind of makes sense. Of course, I already know what it is ahead of time, but this is what you would do. This is like me just showing you my thinking process. You would just go here and then find whatever name kind of fits what you're trying to do. So in this case, it's actually just going to be the entity interact packet, if I can find it. It's really annoying that this is not sorted alphabetically. Here it is. It's just called interact. So if we click it, it says this packet is sent from the client to the server when the client attacks or right-clicks another entity. So the target XYZ fields represent the difference between the vector location of the cursor at the time of the blah blah blah. We don't care about that. So this is a play packet because it deals with the gameplay. This is a bound to the server packet simply because it's sent from the client to the server. And this is all the information in the packet, which is pretty important. So the first one is the most important thing that we care about currently, which is the entity ID. This is an integer value for the entity ID. And so this is simply the ID of the entity that we just attacked, potentially. And this second one's also pretty important for what we're trying to do. This is the type. So we have three different types. We have interact, attack, or interact at. So of course we want to look for attack types. So now that we have an idea of which packet we're trying to listen to, we can go ahead and start coding. So we could do if event dot get packet type packet type dot play, because it's a play packet, and then we're going to choose client because the origin is from the client, and then after that we're going to find the one that makes sense. So it's going to be interact entity. So something that you can do when you're working with these packet listeners is get the user. So we can do this by doing user is equal to event dot get user. And so this is a cross-platform user, meaning that it works for any type of platform that you're working with. So Spigot, Velocity, and Fabric, stuff like that, right? Because this plugin, because this library, of course, works for any of those different types of platforms. So this class here defines a bunch of methods here that you can use in a cross-platform way. So we can send a message, for example, regardless of what platform you're using, which is pretty powerful. It's a nice level of abstraction. You can send titles, you can send packets, you can close the connection, you can close their inventory. Pretty useful stuff, I must say. There's some other pretty useful classes that you can utilize, like the Spigot conversion util class. It has a bunch of methods that you can work with. So this one will take an item stack and then give you a bucket item stack. So the one that it's asking for is an item stack that is provided by the packet events library. But of course, since we're working with bucket and Spigot, we may want to convert that to an actual bucket item stack. So this is where this is pretty useful here, okay? We don't really care about that at the moment. It's just important to know that there are utility classes within this library that are pretty useful. So now that we've correctly determined that this is an interact entity packet, we want to figure out what entity it is, and then also if it's an attack a type, as we talked about before. So when it comes to extracting information from packets or setting information on packets, the best thing to do is use a wrapper. It makes your life way easier. So we would do something like wrapper. And we have all these different wrappers here provided by packet events. We're talking about just classes that essentially wrap the data within the packet, so you can actually access them really easily. So this one would be a wrapper, play, client, interact entity. So now we can do packet, and we simply do new wrapper like that, and then just pass in the event. So this will automatically take the event that is, being listened to here and convert it to the wrapper play client interact entity packet. So now if we want to extract information from this packet, it's really easy. We just do packet dot and then get action or get hand or get entity ID, get target, get client version. So we want to go to do packet dot get action. And we want to say if it's not interact action dot attack. If it's not attack, then we just want to return because we don't really care about any other types. But if it is an attack packet, then we want to get the entity that was attacked. So we can do int entity ID is equal to packet.getEntityId. It's so easy with this library. So now to get the entity, it's actually really annoying what we have to do here. So if we do bucket.getEntity like this, it actually requires a UUID, which kind of makes sense, right? Because that's just an identifier. But what we have here is an integer, and you can't really convert an integer to a UUID as far as I know. That doesn't really make sense. And there's not actually a method that you can use to get an entity just by searching by its ID. So what we have to do is instead get the world that the player is inside of, and then get all the entities in that world and check to see which one matches the ID. Maybe there's a different way. If you know of a different way, then let me know. So to get the world that this entity is in, we just simply need to get it from the player. So to get the player, we can do player is equal to event.getPlayer, and we just simply have to cast this into a player, and then we can do world is equal to player.getWorld. So let's look at the current world that the player is in. And now that we have that, we could go ahead and do entity is equal to null, and then now we simply can loop through all of the entities by doing world.getEntities. So this will give you a list of all the entities currently in the world, okay? So we just simply need to loop through all of those by doing for, and then we could do this, world.getEntities. So this is just a simple enhanced for loop here. And we could say if e.getEntityId is equal to our entity ID above, then we have a match, obviously. So then we could do entity is equal to e, like that. And then we could break out of this. We don't need to keep going. So at this point, we should hopefully have identified the entity that the player has hit. So what we want to do is do if entity is not equal to null, and now we want to check to see if it's an animal. And there's an easy way you can do that. It's just by doing entity instance of animals. Oh, looks like this is not necessary. That's pretty good. So that can simplify it, because if it's null, then it obviously won't satisfy this. So that's good. And so now that we know it's an animal, we can go ahead and do something like user.sendMessage, or you can do player.sendMessage. You can use either one. And we can say something like you attacked an animal. stop. And so before we actually test this out, I'm just going to tell you right now that this is not going to work. It's actually going to give us an error. And this is because packet listeners here are handled asynchronously, meaning that it's not running on the main server thread. And that's an issue when it comes to entities, because entities, whenever you have to do anything with an entity, you always have to do it on the main server thread, because Minecraft, that's just the way that the Bucket Minecraft server works. It runs on one thread, and whenever you're dealing with entities and other types of objects, you have to do it on that main server thread, okay? So one easy way to make this part here run just on the main server thread is just to Control X cut that, and you can go ahead and do bucket.getScheduler, and then we could do run task. And we have these different options here. We could do run task asynchronously, run task later, but we just want to do run task. So this will just simply take in the plugin instance as well as a runnable, which is just the chunk of code that you want to run inside of this task here. And so now here we just want to put an instance of our plugin. So what I'm going to do is simply make it so that we do private packet events tutorial plugin, and then we have the constructor. So we can generate constructor by doing code, generate constructor, bada bing, bada boom. And so now we could go down here and use plugin. And then here we define our runnable. So this is just a chunk of code. So you could do control space. This will auto suggest what you can put here. So this would simply be this first one here. We could open this up with a code block. This is a simple lambda that we're using here. So here we just paste our code that we just cut before. So this is going to be the code that's going to run on the main server thread. So what will happen essentially is it's going to handle this, this listener here asynchronously. But then when it reaches this point, it's going to take this chunk of code and run it on the main server thread, so we can avoid any issues with that when it comes to our entities that we're working with here. So something pretty useful also in the example that we have here is that it gives an example of how to do this using a slightly different method using an executor, but it also tells you how you can copy the information within the packet that you're working with. So this is kind of important because since you're working with an asynchronous method here, this information can be overridden because it's asynchronous. So whenever you want to use this packet information from the event within your main server thread that you're working with, potentially, you simply call event.clone. So this will clone into a separate object that you can work with, and you just use it regularly inside of here. And then once you're done, you just do copy.cleanup to free that memory that you just cloned, okay? I'm not showing this in my current code because we're not using the event inside of our bucket runnable, but if you need to do that, I recommend following this example here where you just copy it, and then you could use it and clean it up. Anyway, so hopefully this all makes sense. Let's go ahead and test it out on the server to make sure that it works. But of course, we need to register this first, so we'll go back to our main plugin class, and then down here we're going to do packet events.getAPI.getEventManager.registerListener, and we're going to do new animal hurt listener. Pass in this because we modified that constructor to accept the plugin instance, and now we can do packet listener priority normal. Alright, so we found a cute little pig here. We're going to go ahead and smack him, and it says you detect an animal, stop. So this means that our packet listener is definitely working because it was able to detect the interact entity packet, determine that it was a attack packet, and then also determine that it's an animal that we just smacked, because that's the conditions that we had to be able to see this message here. So now what we're going to do is actually update the player's health using a packet, and we're just going to set it to a random value. And luckily, since we're using this awesome packet events library, sending packets is so easy. It's just simply 2 lines of code. So we're going to go back to our code here, and then where we do send message, right under that, we're going to make a new wrapper, play server update health packet. So this is going to be sent from the server to the client, obviously, and this is going to be a health packet. And so now in the constructor, when we create a new object here, it's asking for either the events, because whenever you're listening, this is how you get the information from the packet that you're listening to. But in this case, since we're actually sending this packet ourselves, we use the other version of this constructor, which is the actual information of the packet. So in this case, it's asking for float health, integer food, and float food saturation. So we want to make it so that it sets the health to a random value. An easy way to do that is just by doing float health is equal to math.random times 20 plus 1. So that should be any float, just 1 through 20 essentially. So we're going to go ahead and take that and make sure we cast it to a float. And now we just pass in our float here, so health. And now we don't really care about our food or saturation level, so we'll just set that to 1 and then 0.0f. Those are just random values that we're going to set for that. So now that we've created this packet wrapper here, we can go ahead and send it to the player. And we could do that really easily by doing user.sendPacket and just pack in, and then just pass in the health packet. There we go. And now for some reason, if you want to send the packet to a different user that's not involved in this listener that we're working with here, or maybe if you just want to, send a packet somewhere other than a listener, you could do that by doing packet events.getAPI.getPlugin or player manager, and then you could do send packet, or you could get the user and then send the packet through the user. Up to you. Okie dokie, we're on the server now, so if we smack this little pig here, As you can see, our health was just changed. So it's being set to random values if you just watch it. Stop running, damn. So they're all pretty close together, but yeah, you can tell it is random. We just went down to 1 heart. So it's definitely working. So that means that we're able to send packets now. So just as a recap, what we did here is we made a new packet listener, and then we overrid the on packet receive method so that we can listen to packets that are sent from the client to the server because it's on packet receive. And then we check to see what type of packet it is, so we can see if it's a interact entity packet. And then if it is, we want to get the user involved, meaning the user that sent the packet from the client to the server. And then we want to get the wrapper. So we're taking this information within the event and then putting it into a wrapper so that we can grab information from the packet. And we're saying if it's not an attack packet, we're just going to return. We don't really care about those. And then we're going to get the entity ID, the entity that was hit by the player. And then we're going to say get the player in the world that the player is a part of. And then using that entity ID, we're going to track down which entity the player hit. Check to see if it's an animal. If it is an animal, we're going to send them a message, give them a random health value, and actually send the packet using the wrapper and using user.sendPacket. And then finally, we're using our bucket.getScheduler.run tasks because we need it to run on the main server thread because we're working with entities here. All right, so that's it for this listener here. I want to give you guys one more example that was actually provided by ReTrooper, which is the creator of this library. And this is to make it so that villagers will look at you. So the idea of this is that we're going to listen to player movement events, and we're going to see if the player is near a villager, like maybe 5 blocks near a villager, we're going to make it so that the villager looks at that player. And since we're using packets, only that player should receive that packet to make the villager look at the player. So the other players on the server are going to not see that happen. So what that means is that every player on the server could have the same villager look at them individually. So this is why packets are so awesome, is because you can create this interesting behavior. Okay, so we're going to make a new listener here. We're going to call it the villager look listener. And instead of a packet listener from packet events, we're going to use a regular bucket listener. And we want to listen to the player movement event. So public void on player movement. This is going to be player move event E. So every time the player moves, we want to go ahead and check to see if there's any entities around them, if it's a villager, and then if it's a villager, we want to make the villager look at them. So we could do e.getPlayer.get nearby entities. And now this is going to accept a range. And we only really care about like the 5 blocks around the player. So we're going to do something like 5, 5, 5. So that hopefully should give us a 5 block radius. And so this will give you simply a list of entities to work with. So we're going to use a stream, and we're going to go ahead and do filter. We're going to filter by villagers only. So we're going to do entity and entity instance of villager. Instance of villager. So the only thing left in this list after this filter here will be villagers. So now for each of the villagers that we have found within our 5 block radius, we can do for each entity. So I've already identified the packet that we would use in this case. It's just called headLook. This is a client-bound packet, of course, because we're telling the client that this villager, this entity on the server has looked at you. So it's going to be wrapper, play, server entity headLook. We're going to call it packet is equal to new wrapper play server entity head look, and this is going to accept only an entity ID and a float head yaw. So the entity ID is actually pretty simple. That's just going to be entity.getID or get entity ID. And then for the head yaw, this is simply the rotation that the head needs to make to be able to look at the player. And I don't know, trigonometry is hard for me. I don't really like working with degrees and rotation and stuff like that. So what I did is I asked ChatGPT how we can essentially take our entity location and our player location and then calculate the yaw needed to make the villager look at the player. And so it gave me these beautiful methods here that we can utilize. I'll copy and paste it. There we go. So this will take the location of the entity and the player location and just do some math here to calculate the yaw that is needed. So we can go up here and do float yaw is equal to calculate yaw to face player. So we could do entity.getLocation and then e.getPlayer.getLocation. So that should give us the yaw, and now we could just go ahead and pass it in. There we go. And so now we need to actually send this packet to the player. So like I said before, the easiest way to do that is just by doing packet events .getAPI.getPlugin or player manager, send a packet, and now it's asking for the player and then the actual packet that we want to send. So we'll just do e.getPlayer and then packet. And that's it. So hopefully if we did this right, this should make it so that every time a player moves, we get the villagers within the 5 block radius. If there are any, we're going to make it so that the villager looks at the player by sending a play packet, which is a server entity headlook packet, which just contains the entity ID that we want to make look at them, as well as the yaw. Okay, so I have spawned a villager up here. I've trapped him. And currently he's not looking at me when I get nearby. That's because he's not in my 5 block radius. But if I sneak up closer As soon as I get close to him, he'll lock onto me. There we go. And if we move around, he will continue looking at me because every single time we move, we'll listen to that bucket event. We'll go ahead and calculate the yaw, and then we're going to go ahead and use the packet to make it so that he looks at me. So currently, he's not actually looking at me if you really think about it, because we're kind of spoofing this packet, sending it from the server to the client. So for other players, it won't look like he's looking at me because I'm the only one receiving this packet here. All right, guys, so now that we have an understanding of different things that we can do with packet listeners and an understanding of packet wrappers and all that, I'm going to show you guys how to fix our time listener that we made earlier in the video to make it so that the time will always stay the same no matter what. Now, previously in the video, when we went over the time packet, I really just ignored the two data fields that are part of the packet that explain what data the packet holds. So let's go over that to see what data we need to manipulate. So here it's actually useful that we come back to this packet description, the update time packet, and before I just ignored these two fields here. This is the data of the packet. So the first one is world age, and this is a long, and then we have time of day, which is kind of what we're trying to aim for here. And this is a long as well. So this is the world or region time in ticks. If negative, the sun will stop moving at the math.absolute of the time. So what we need to do instead of canceling this packet here is actually just replace the data inside of it with a constant value that never changes. So if you want to make it morning, which is just 0, we'd put 0 in place of the time of day field for this packet here. So instead of intercepting and then canceling the packet, we're going to be intercepting and then modifying the data within the packet. So here we're going to use another wrapper just to encapsulate the data within the packet. So we're going to go ahead and do wrapper play server time update. We're going to call this just packet, and then we're going to do new wrapper play server time update, and then just pass in the event. So now all the data within the packet event has been encapsulated into this packet wrapper here. So now we could do packet dot, and we have set time of day and set world age, which correspond to the two fields of the packet that we just saw. So what I'm going to do is change this one here, so set time of day, and we're going to make it 0L. And I'm doing L because if we do control P here, it's asking for a long. So that should be all we have to do. We're simply listening to the packet same as before, and instead of canceling it, we're going to modify the data within the packet. And now let's go ahead and throw this updated code onto the server to test it out. Alright, so I'm back on the server now, so we can go ahead and test this out. I did /reload confirm, and if we look closely here, the sun is now not moving. It's moving very slightly, but it's being reset every so often. You can see very clearly that it's not moving anywhere. So the time now will be fixed at this specific time here and that's just simply because the server is now able to send packets to the client, same as before, except that we're modifying it so that the time is always the same. So it's always going to stay at this value here, okay? Pretty cool, right? It's kind of crazy how simple it is just to modify the data within a packet. You don't have to resend it or anything like that. The data just sort of updates automatically. So hopefully you found all this interesting. Hopefully you can see why packet events is so popular now and why it's something I wanted to show you guys, because it's really easy to use. It's really easy to get started. It's a great alternative to protocol lib, which is also very, very popular. Again, it has many benefits like cross-platform support, cross-version support, which is awesome. It's being updated pretty frequently as far as I can tell. I recommend you join their Discord though. I have a link for this in the description as well. If you're using this library and then you're stuck on something, you could join their help channel and ask for help there. And they have some other helpful channels as well. There's one where you could view other plugins that utilize this library so you can see some code examples, which is very cool. And that's all I got, so thanks for watching, everybody. Peace. So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.